Okay, so today we're going to be talking about section 3.3, which is all about polynomial and synthetic division. This is something that you learned about in Algebra 2, so most of this should look familiar to you, but we're going to go over it today and we're going to add a theorem at the very end of our notes today that relates to everything. Okay, so before we jump into dividing polynomials, let's first just talk about what long division is. This is something you learned way back in elementary school, but just to refresh, we have this tells me this is what I'm dividing. You'd look at your 5, we'd see I can't do 1 divided by 5, so then I move, and now I look at 12 divided by 5. 5 goes into 12 2 times, so I put that up top. Then I would do 2 times 5 to get 10, and I would subtract these two numbers from each other. So I have 12 minus 10 gives me 2. Then I bring the 5 down. I bring one digit down. And now I do that same process. So I would do 5, and I'd see how many times can 5 go into 25? Well, it goes into 25 5 times. Last step here, we do 5 times 5. I get 25. I subtract, and I get 0. Okay? So again, that is a review. If that feels super comfortable and familiar and you've got that down, then our long division should come quickly today, okay? It's not much different. We're now just going to throw in some variables. So if you ever get stuck on synthetic, just come back to the basics. Think about what the process is when we just have numbers. Okay? All right, let me erase that to give ourselves some room here. And let's just dive into our first problem. All right, so my first question here is saying, let's take a look at, and then I give you this equation. If I were to tell you that x equals 2 is a 0, meaning it's an x-intercept, you can use long division to find the remaining polynomial function, okay? So let's just talk about what this means. When we talk about long division, okay, we are going to be dividing a polynomial by a binomial or a trinomial, okay? So let me say that again. So we're taking a polynomial and we're going to divide it by a smaller degree polynomial. So I have the first one. I'm going to just copy it down. My 6x cubed minus 19x squared plus 16x minus 4, okay? That's what I'm dividing by something, okay? That's my starting one. Now, if I had, let me change my color real quick. If I had a 0 of x equals 2, if you think about going backwards, what would have resulted in that value? Well, it would have had to have been x minus 2. That's what would have given me that x equals 2 value, okay? So in other words, this binomial is what I'm now going to divide my f of x by, okay? All right, so now let's actually try this. So the way you need to think about this is we're going to look at our first term here, okay, my x, and we're going to kind of think backwards. So think reverse of division. What would I need to multiply by that x value to get 6x cubed? Again, what would I need to multiply by x to get 6x cubed? Okay. Well, I would need to multiply it by 6x squared. Okay, so we would come over here and we write 6x squared up top. Okay, notice I'm keeping it in line too. Here I have my squares on top of each other. Okay, so now just like our long division, we're going to multiply now. So I'm going to take this and I'm going to give it to both things in my binomial. So 6x squared times x gives me, and I probably should have used a different color here, so let me just change my colors. Okay, so again, I'm multiplying that number now by my binomial. So I have 6x squared times x. That gives me 6x cubed. Then I have 6x squared times negative 2, which gives me a negative 12x squared. Okay? And now, just like our long division with just numbers, we're going to subtract our new binomial by what was in my original problem. Now, we have to be careful here because really what's happening is we're subtracting this whole binomial. So there's a set of parentheses around there, if you will. Okay, that matters because since we're subtracting, you need to pay attention to any sign changes that are going to happen. So, for example, this first one's 6x cubed minus 6x cubed. Well, that's nice and easy. That just becomes a 0, which is what I want. Okay, so there's nothing there. Now, the next one, I'm doing negative 19x squared minus negative 12x squared. So, really, this is becoming a plus. Okay, that's why we have to think about it that way. So, negative 19 minus a negative 12, that gives me a negative 7x squared. Okay, again, following the process of numbers, I bring the next part down. Okay, and now I repeat the process. Okay, so now, let me erase our errors here. Now I'm looking at my leading term. What times x would give me a negative 7x squared? Well, I could multiply by a negative 7x. So if I multiply by a negative 7x, now I just need to multiply that. I need to give it to both terms of my binomial. So I have negative 7x squared plus 14x. I'm going to subtract my two binomials. So my negative 7 should go away. That's the goal. Then I do 16 minus a positive 14. So 16 minus 14 gives me 2x. I bring my minus 4 down. And the last time we have to repeat this process, I look at my leading coefficient here. What times x would give me a 2x? Well, I'd multiply by 2. So I'd do times 2 up here. So that, when I distribute it in, gives me 2x minus 4. I subtract, and I'm left with 0. We call this our remainder. Okay? That number that we get at the very end is considered my remainder. Okay? And now, because I get a 0 here, we'll talk about this more later, but that's just proving our statement up here, that x equals 2 is a 0. Okay? That's what we just did using long division. Okay? So we already knew that it was going to be a 0, that it would get no remainder down here. We were just showing that. Okay? My answer to this would be I could take my f of x that we highlighted up here. I could take this, and it's not totally factored, but I could factor it where x minus 2 is its own thing, and then 6x squared minus 7x plus 2. And that comes from up top up here. Okay, these are two factors, meaning if I multiply them together, I would get my function up here. Okay, so this is just another way to factor, I guess, if you will. Then I could keep factoring if I really wanted. Okay, we'd factor by grouping. So I'd have 6x squared minus 4x minus 3x plus 2. So I just split up my 7x. I did that kind of fast. Okay, just for time. And now I'd keep going. So this would become 2x, 3x minus 2 minus, I guess the GCF here is just a 1. So I'm left with 3x minus 2. Bring down my x minus 2 still. Oh, I need parentheses here. And I'm almost done. Again, factor by grouping. So I have 2x minus 1 3x minus 2, and then my x minus 2. So again, all I'm doing is factoring now. So my zeros would be x equals 2, x equals 1/2, and x equals 2/3. Okay? So really, all that we're doing today is we're talking about a new way we could find our zeros, especially when I have a pretty high degree polynomial that looks like a really big nightmare to factor. Okay? We just factored it, starting with long division. All right, I want you to try this next one. So pause the video, and I want you to try the next one on this page. All right, so here's our work for this one. Okay, again, notice everything's lined up. I started by looking at what do I need to multiply by x to get x squared. Well, I just multiply by x. Then I distributed that in, and I got x squared plus x. Okay, remember we're doing 3x minus x, and that gives me the 2. Then I use this term as the one that I determine what to put up top. Okay, so what times x gives me a 2x? Well, a 2. So 2, give it to both terms. Now this time I have a remainder of 3. Okay, now when I have a remainder of 3, this is how we write it. Okay, so the first two parts here comes from the up top. Okay, the second part at the bottom comes, the numerator is my remainder, and the denominator is the binomial that I was dividing by. Okay, now notice this one I don't factor anymore. Okay, I'm not factoring to finish this problem out because what I just found, and what we'll get to later here, is that this actually doesn't help me find a 0 at all. Okay, it's not helpful for me to finish this problem. Okay. All right, let's look at our next page. Now, I should have covered that up. Okay. Now notice here, let me zoom out actually, let's look up top. Here we have a problem. Okay. And this is a long division problem with all numbers. Now this is a pretty big number. Would you say that I could just, because those are zeros, get rid of them and just do this? In other words, I just kind of take those out. No, these are two very different problems. Okay, they're not equal to each other. Okay, in a way, these zeros are kind of like placeholders, right? They're holding the place of these 100 and 20 and 10 values. Okay, the same goes for variables. So, for example, my highest degree here is a 3, and then I don't have any other exponents. So really, what I'm missing here is I need an x2 and an x. But if I don't write them, what's their leading coefficient? Well, it's just a 0, right? So in other words, when we do our long division, we need to make sure we have placeholders for any missing variable and their exponent. Okay? So my goal is to always have my exponents in descending order. So I have a 3, a 2, a 1, and then nothing. Okay? Now my original problem didn't have a square or a linear term, but I need to include one whenever I set up my problem. Okay? All right, so here's this one. So again, if you notice here, I have my placeholders now. So I took my original problem and I expanded it. I'm dividing by this binomial. Well, what I need to multiply by x to get x cubed? Well, an x squared. So I plug that in up top. I give it to both terms. Then I subtract them. Okay, notice here we have 0 minus a negative 1. That's what gives me the positive 1 here. Okay, bring my term down. Finish my problem out. Notice I get a 0, which tells me that x minus 1 is a factor. Okay, and what would be left over is x squared plus x plus 1. Okay. All right. This next one. Okay, I want you to try this one on your own, but before you start it, notice that my two functions, my polynomials, are not written in standard form. Okay, we have to have them written in standard form in order for us to be able to do long division. Reminder, standard form means we're in decreasing degree order. Okay, so remember we got confusing last chapter because we talked about vertex form, and now when our textbook says standard form, it means vertex form. When I say standard form now, for polynomials, I'm thinking back to decreasing or descending degree order. So in other words, this one, let me highlight it. This one, we would need to rewrite, let me make this purple. My 2x fourth would be first, plus 4x cubed, minus 5x squared, plus 3x minus 2. Okay, so that's how we would need to rewrite that. And then my binomial also needs to be written in standard form. Okay, so we would rewrite this one, x squared plus 2x minus 3. Now you're ready to divide. Go ahead and pause my video and practice your long division. Okay, so here's our work, okay? We plugged in, like I said, my new problems in standard form. Now notice here in this one, we're dividing by a trinomial, okay? I didn't necessarily preface with that, but we follow the same steps, okay? There's only one thing that shifts. So I have a 2x squared, because that's what I would multiply by x squared to get 2x to the fourth. Then I would need to give that 2x squared to all three things. So I end up with a trinomial over here. Okay, we subtract, so these go away. Those conveniently go away. Then I have negative 5 minus a negative 6, which gives me a positive 1. Now, this is the only little new part. In the past, we only brought down one of our terms. Okay, but now, because I'm dividing by a trinomial, I need to have a trinomial right here. So I'm just going to bring down both terms. Okay, then I look at my leading coefficient. What do I need to multiply by x squared to get x squared? Well, I need to multiply by 1. So I put a plus 1 up here. I distribute it to everything inside. We end up with a remainder of x plus 1. And again, this is how we write my final answer. We have our solution from the top, plus the remainder is my numerator, and then what I divided by is my denominator. Okay? All right. Let's talk about synthetic division. Okay, so synthetic division, I've noticed students prefer because synthetic division gets rid of the variables. Okay? Gets rid of the variables. You don't have to think about exponents anymore. All synthetic division is we're looking at the coefficient. Okay? So down here, how I set it up is my 0. Okay, so if this is the problem, my 0 would be x equals negative 3. And that negative 3 is what comes out here. Okay, so your 0 is always on the outside of your box. Then on the inside of the box, I don't want that color. On the inside of the box is my leading coefficients from the problem. Okay, so I had a 1 right here. Oh, notice I don't have a 3, which means I need a placeholder. That's what's happening here. Then I have a negative 10, negative 2, and a 4. Negative 10, negative 2, 4. Okay? Once we have these in here, let's talk about now how we solve. Okay, so that was just setting it up. Now let's solve it. Okay, we always start by bringing the first number down. Okay, so we put a 1 there. Okay, it doesn't matter what that number is, we always bring it down. Now I'm going to take my 0 from out front and I'm going to multiply it by the new number down below. So I have -3 times 1, which gives me a -3. Once I plug in the -3, I'm always going to add this row. Okay, so for example, I'm going to do 0 plus -3 to get -3. And then the process repeats itself. So now I have -3 times -3, which gives me a 9. Then I add -10 plus 9 gives me, let's use the same colors here, gives me a -1. Okay, and let's keep going. Now I do -3 times -1, and I get a +3. Then I add them. -2 plus 3 gives me a 1. And last but not least, -3 times 1 gives me a -3. 4 plus -3 gives me a 1. Okay? Now, here's what our answer means. Okay, so now we just have this big list of numbers down here at the bottom. Box in that last number for me. So let me get out my red. This number right here is my remainder. Okay, that last number is a remainder. The rest of the numbers are my leftover coefficients. Okay, so in other words, my remainder here we know is 1 over x plus 3. And again, that x plus 3 comes from up here. Okay. And now we just have the rest of our terms. So I have a 1. Okay, I'm going to have another -1. I'm going to have a -3, and I'm going to have a 1 coefficients. And now we just plug in our x values. Okay, so here's all these x's. Now, they can't all be x. Okay, in fact, my last one is my constant, actually. So I got a little carried away there. Okay, so we have our constant term at the end. Then we have, so here's our constant. Then we have our linear term. Then here's our quadratic term, so it gets a little 2. And then my cube term, okay? And this is a positive at the end, so let's put a little plus sign right there just to make it most accurate. But that would be my final answer, okay? All right, let's try this one. Okay, again, notice I have a missing linear term here, so I'm going to need to have a placeholder in there. So go ahead and try this one on your own. All right, so here's my work for this one. We get kind of an ugly remainder here with this one, okay? I plug in all my values. I have my 0 outside. I follow the process. My remainder is -133 over my x plus 4. And I bring the rest of my coefficients down. All right. Now let's get into some theorems here. So remainder theorem. Okay, the remainder theorem, all that says is, I'm reading this right here. If a polynomial f of x is divided by x minus k, the remainder is r equals f of k. Okay, now let's see what that actually means. Okay, it's kind of cool. We can use synthetic division to find the values of points, to find an x and y. Okay, so let's just test it here. So here's our first one. It says use the remainder theorem to evaluate the following function at x equals -2. Okay, well, I'm going to take my -2, and that's what goes on the outside, because that's what I'm testing. And now I have the leading coefficients, 3, 8, 5, and -7. Okay? let's do our synthetic division here. So I bring my first number down. Then I'm going to multiply. I have negative 2 times 3, which gives me negative 6. Then I add. So I get a 2. I repeat this process. Negative 2 times 2 gives me a negative 4. I add them, so I get a 1. Negative 2 times 1 gives me a negative 2. Add them up, so I get a negative 9. Okay? Now, a couple things we can tell from this. The first thing we know, okay, is how to write it, right? We talked about our leading coefficients. This would be a 3x squared plus 2x plus 1. And then we'd have a remainder of negative 9 over x plus 2. Okay, so that's one thing we know. This new remainder theorem, though, is pretty cool. What it tells me is f of negative 2, so f of my number here that we put on the outside, or my 0, equals my remainder, okay, equals my remainder of negative 9, okay? So in other words, our remainder theorem tells us a point, negative 2, negative 9. I know is a point on my graph, okay? And we could check this, right? Let's come down here and let's actually check it. So what we just said was if I took f of negative 2, I should hopefully get negative 9 here. Okay, so if I plug this in and I go to solve it, let's see, we've got 3 times negative 8 plus 8 times 4. That should be a minus 10 minus 7. If you were to simplify all that, we would get negative 9. Okay, so that's the remainder theorem. So it's pretty cool. It's just like a new way of figuring out an x and a y value. All right, last little bit here. The factor theorem, okay? We say something is a factor theorem if a polynomial f of x has a factor, x minus k, if and only if f of k equals 0. That if of only if is really powerful. That means it has to hold, okay, for this statement to be true. No ifs, no buts. This has to be 100% foolproof. Okay, so let's just see what this means. And it's definitely easier to see with an example. So it says, show that x minus 2 and x plus 2 are factors of f of x. Okay, so in other words, we're going to test each of these factors. So the first one, the 0 in this situation would be 2. The second 0 we're going to have to test is negative 3. So let's do 2 first. So I set up my division here. Oops, actually, it's a little big. Set up my division. I'm in standard form. Good. So I've got 2, 4, negative 27, negative 18. Okay. So that's just me setting it up. All right, now let's solve. So I bring my 2 down. Now I'm adding. Okay. Okay, so I multiply 2 times 2, I get 4. 7 plus 4 gives me 11. Now I repeat that process. So 2 times 11 gives me 22. Negative 4 plus 22 gives me 18. 18 times 2 gives me 36. Negative 27 plus 36 gives me 9. 2 times 9 gives me 18. Negative 18 plus 18 gives me 0. Okay, so what we just did, according to my factor theorem, is because I got a 0 here, I know that x minus 2 is a factor. So I know that I can take out an x minus 2, and I'd be left over with, well, what comes up from up here, okay? Sorry, not up there, here. What I have with left down here, okay? So in other words, I have left over 2x, let's see, linear binary triangle, yep, to the third plus 11x squared plus 18x plus 9. Okay, and again, that comes from down here. Okay, I'm just adding letters to it now. Okay, so we've shown that x minus 2 is a factor, so now let's just show that x plus 3 is a factor. So now we're going to test our negative 3. And this time, we actually can use this polynomial as the coefficients for our new synthetic division. Okay, so in other words, instead of coming back and using my original one, I'm going to use the new one that I have left over after I take out the x minus 2. So I've got 2, 11, 18, and 9. Now we just do synthetic division. So I bring down the 2. Negative 3 times 2 gives me a negative 6. I add them up to get 5. 5 times negative 3 gives me a negative 15. I add them up to get 3. Negative 3 times 3 gives me negative 9. I add them up and get 0. Again, because I just found that 0, it tells me that this is a factor. That's what our factor theorem tells us. And now let's just finish this problem. So I already showed that x minus 2 is a factor. Now I just proved that x plus 3 is a factor. And my answer here at the bottom tells me what I have left over. I've got 2x squared plus 5x plus 3. Now let's find our zeros. Okay, so to find our zeros, we got to start by factoring out my trinomial here. Okay, so this would factor, we've got 2x squared plus 3x plus 2x plus 3. Yep, that's how that would factor by grouping. Okay. And now let's factor. So we can factor out in my first term here. We take out an x. I'm left with 2x plus 3. The next one, I can't really take out anything. All I can take out is a 1. So I'm left with 2x plus 3. So to simplify, I've got x plus 1, 2x plus 3. I bring down the other two binomials that I found already. And now my zeros would be x equals 2, x equals negative 3, which we already proved over here. Okay, we already did that. And now my new ones, x equals 1, negative 1, and x equals negative 3 halves. Those would be my zeros. Okay, so again, synthetic division is just another way of finding our zeros. Okay. The biggest thing too here is that we have to get 0 for that to work. If I have a remainder, this will not work.